Okay, so here we are, week 3, day 2, and we need to talk about sequences. So just to kind of get us going with sequences, I'm thinking, can you come up with a little definition for what that is? Basically, it's a set of numbers and normally they're divided by commas, and normally represent a particular pattern. Okay, so a sequence of numbers. We can do one. For instance, there's the Fibonacci sequence. Everybody's heard about that one before, Fibonacci. If you haven't heard about the Fibonacci sequence, oh, you should take my math history class. So there. We talk all about Fibonacci in there. So the basic idea is that you have the numbers 1 and 1, and you start out with those two, and then you always what? Add the 2 before. So if I add 1 plus 1, I'll get a 2. If I add 1 plus 2, I'll get a 3. If I add 2 plus 3, I'll get a 5. If I add 3 plus 5, I'll get an 8. If I add 5 plus 8, I get a 13. And you just keep on going, 21, 34, and 55. And so on and so forth. It doesn't stop there. I'm just literally out of space there on that line. So you just keep on going until you have all those things. And you have to, in order to find the next term, you don't just need one, you need 2 terms before. Right? That's kind of the idea there. So this is definitely what? A recursive pattern. Okay? And remind you, recursive pattern is one that uses the previous term or terms to determine the next item in the sequence. So terms in a sequence, they have specific little notations. Sometimes this notation bugs people, so I'll try really hard to kind of use it and make sure I say what it is. So the notation for terms in a sequence will look like a variable with a subscript. A variable with a subscript. So in other words, a sub 1 is the first term. It's the first A that I get, okay? And again, that's called, A sub 1. That's how we say it. So the next one would be A sub 2. That's the second term. A sub 3. That's the third term. And so on and so forth, right? Okay. So eventually, I don't want to always be recursive. We've already talked about that. So I'll have the 4th term and the 5th term and the 6th term and all that. But eventually, I'm going to want the A sub n, which is the nth term. Okay? Nth term just means, hey, they're going to tell you, oh, find the 20th term. And I know I can find the 20th term because I have the nth term, which means I have the general pattern. Okay, so in order to get there, just like we did for the don't fence me in problem with the cows last time, in order for me to get to the nth term, I need to find that general pattern and be able to see it. So, some examples of how this works, just so you can get used to the notation. You might see something that says like, example 1, A sub n is equal to negative 1 to the n divided by 3n. Okay? And then I'll say something like, find the first 6 terms. Okay? And you're going to have to be able to interpret that. So this is the general formula for this, or the general pattern that I'm after, and it says find the first 6 terms. So you want to come back and do what? Yeah. You want to find, for instance, a sub 1, because that's the first term. So what would I do? Everywhere I see, instead of an n now, I don't have an n there, I have a 1 there. So this is a lot like our function notation, right? We've seen that kind of thing happen before. Whenever I have a variable and I substitute it out for a whole number in this case, I'm just going to substitute. Everywhere I see an n, I'm going to plug in whatever term number I'm on. So I'm on the first term here, so I'm going to plug in -1 to the, instead of n, it's going to be 1, over 3 times, instead of n, it's going to be 1. Okay, and then what happens on the top? -1 to the first power is still -1, right? And on bottom, 3 times 1 is 3. So my a sub 1 term is -1/3. Or the first term of my sequence is -1/3. That's how we would use that notation, or that wording, verbiage there, okay? But we're not out of the woods yet, right? Because it said find all 6 terms, the first 6 terms. So I have the first term, now I need the second term. That's going to look like what? Yep, a sub 2. And I'm going to do the same thing I did, but instead of n, I'm going to put in, I didn't put in a 1 this time, on the second term. Now my n equals 2. So I'm going to stick in a 2 there. So instead of 3 times 1, it's going to be 3 times 2. -1 squared. Oh, whenever I square a negative number, it becomes a negative times a negative, right? So that's positive 1 over, and that's a 6. So my second term is 1/6. And then my third term, y'all work it out. Pause the tape for just a second and work that out. Okay, pause the tape. Dating myself. Okay, pause the video. All right, did you do it yet? All right, -1 to the third over 3 times 3, right? This becomes -1 still on the top. 3 times 3 is a 9 on the bottom. Okay. So I'm starting to see stuff happening here. I see on the bottom I'm getting basically all the multiples of 3. And then what's happening on the top? -1, +1, -1, +1. So I see a pattern going on. I don't have to keep on going. If you need to, go ahead and find a sub 4, a sub 5. If you want to work them out and use the general pattern to get them, go for it. Okay, a sub 6. Figure out what those are. I'm saying right now, my guess is this is going to go negative, positive, negative, positive, because this would be -1 to the 4th, right? That's positive because it's even. Negative, positive on the top, and then I'm saying on bottom it's 3, 6, 9, 12, 15, and 18. And you can just keep on going if you, and try them all in the general formula. See if you can figure that out. Okay, so let's double check and make sure we got this, and we can see what the 6 terms are, because that's what it asked me to. So the first 6 terms are, if I'm not mistaken, if I didn't make any mess ups, -1/3, 1/6, -1/9, 1/12, -1/15, 1/18. This alternating negative sign thing on positive, negative on the top and bottom, that just gives me alternating patterns. That's okay. But I definitely see the multiples of 3 thing coming out on the bottom, right? Okay. So let me scoot that up. Another notation you may see as you start working through these sequences is you might see the factorial notation. Okay, the factorial notation looks like, and it's always going to be some whatever number or variable or whatever, I'm going to use n in this case, with an exclamation mark on it. Okay, and again we read that in factorial. Does anybody know what that does? I hope you do. Some of you have seen this before, I think. But if not, it's okay. In factorial is always going to be whatever the number is times n minus 1, so I'm going to go down by one whole number, times n minus 2, times n minus 3, dot, 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 and keep on multiplying like that until we get down to 3, 2, and 1. Okay, so we keep on subtracting 1 from what we're multiplying by until we get all the way down to the whole number, or to the natural number 1, right? We're not going all the way to 0, so not quite whole numbers. Okay, so an example of this, so you can see what that would look like, let's just say 5 factorial. Okay, well, the n here is 5, right? So I'm going to say n is 5 here, times n minus 1. 5 minus 1 is 4, times 3, n minus 2 is 3. And look, I don't have to do all this. It cuts me all the way automatically down here to the 3, and then times 2, and then times 1. So I just multiply out 5 times 4 times 3 times 2 times 1 in factorial. And you'll see this, by the way, this particular notation, it comes up sometimes on the state board exam. I've seen it come up. So you need to know what a factorial is if you don't already, then figure it out. Now this just becomes a simple matter of plugging things into the calculator, or if you're really good with your multiplication tables, that's 20 times 3 is 6 times 2 is 120. So that would become 120. Okay. So what do you think about 4 factorial? Start with 4. Then what? Everybody's done it, right? Times 3, times 2, times 1. Okay. All the way down till I get to the 1. And then I just multiply those out. Well, that's 12 times 2. It's just a 24, right? Okay. I'm going to keep on going down. I'm going to do 3 factorial. Well, what do you think that is? Yep, 3 times 2 times 1. So that's just a 6. And 2 factorial. Yep, 2 times 1. That's just a 2. What about, sorry, I left off on my boxing. What about 1 factorial? Yeah, it's just 1, right? Because I don't have anything smaller than 1 to multiply by, because I'm already basically at the bottom of this chain of numbers, right, that I'm multiplying by. So I'm done there. Okay, but then something interesting happens, just a little notation. If you ever have to do this in some problem, note 0 factorial, always we say, hey, you can't do that because it's below the 1. So it defaults to 0 factorial is 1. Okay? So we're never going to do 0 times whatever because it already is less than 1, right? So I don't need to keep on multiplying, so to speak. Alright, so there's my factorial stuff. Yay! So here comes an example of what that might look like as we use that. So example number 2. So it would say something like, find the first 3 terms of the sequence. Three terms of the sequence. Okay. So if I'm finding the first 3 terms of the sequence, I don't know what happened to my box there, sorry. And I know that the general pattern is a sub n is equal to 2 to the n over n minus 1 factorial. And I want to find the first 3 terms, then you should be figuring out what? What is a sub 1? That's my first term. What is a sub 2? And what is a sub 3? So again, if you'll pause your video and actually work those out and see if you can get there, remembering what the factorial means for me, I'm going to then pick it up and work it. So y'all go ahead and do it, and I'm just going to work it out while you're pausing. So go ahead. Okay, it should be 2 to the first over 1 minus 1 factorial. Oh, look, we have a reason for that knowledge I just told you a second ago. 2 over 0 factorial, but we know 0 factorial is a 1. The second one is 2 squared over 2 minus 1 factorial. That's a 4 over 2 minus 1 is 1. 1 factorial is a 1. That's just a 4. And the third one would be 2 cubed over 3 minus 1 is a 2. That's 8 over 2 factorial. But hey, we know 2 factorial is just a 4. I'm sorry, 2 factorial is just a 2, and then 8 divided by 2 is just a 4. So there we go. All right. So if I want the first 3 terms of that sequence, they are 2, 4, 4. There's my first 3 terms of the sequence. Is everybody all right? I hope so. Okay, once we have that sorted out and we know all about sequences, we have those basic notation type things coming in, then we have to do, oh, it can't be just that easy, right? We have to do particular types of sequences, of course. So there's 2 basic types of sequences. One is called arithmetic. I know it looks like arithmetic, but they put the emphasis on a different syllable. Okay, so arithmetic sequences, and what those are is that the sequence is something that I find a pattern that is adding a constant. So my pattern is adding a constant. Oh, pattern is adding, sorry. Adding a constant. Okay. Adding a constant to get from one term to the other. Okay. And in this case, D is going to be the difference between any 2 consecutive terms. Okay. So I got to know what my D is. It's going to be the difference between any 2 consecutive terms. So in this case, we'll have an example. And that looks like 3, 8, 13, 18, 23. Probably you can see the pattern pretty quickly. I think it's what? Add 5, right? Does everybody agree? Okay, so in that case, then I know that my difference is going to be the difference between 8 and 3. So it's always, you add this direction, going from 3 to 8, going left to right. So then I would find the difference by subtracting, right? 8 minus 3 gives me 5. So the difference here, and again, we're going to call that the D, is going to be 5. Does everybody agree? Okay. So there are some generic little things that we can put in. We'll have a formula in a minute. Oh, before I get there, what are the next 3 terms, so to speak? You could find them very easily, right? So next 3, add 5, right? So what do you think? 28, 33, 38. Pretty easy, right? Okay, whenever we go to do problems like this, though, we'll be like, oh, I would really, again, like to go for the generic terms, the generic pattern, the general formula, whatever you want to call that. I'd rather have that than to have this pattern like this, because even though I see that this is the difference here of 5, I'm still going to always have to refer back to the term before it, right? To get this 28, we had to have the 23. But to get the 23, we had to have the 18, and so on and so forth. So in order to do that, I'd much rather just have a general formula, right? General formula. And this is going to work for the nth term, finding the nth term. And in this case, we're talking about an arithmetic sequences. And it's really important that in your notes or whatever you're doing, you make that note that the arithmetic ones, remember, these are the ones that have a difference in them, because later we'll have other stuff going on. So if they just have a nice, pretty difference in them, then the general formula is going to look like a sub n. Okay, again, what's that? My general pattern. That tells me the nth term, right? Any term I want is the nth term. It's always going to be your first term in your sequence plus n minus 1 times the difference. And the reason why we have that n minus 1 step in there is because whenever I go to talk about this, I already have my first term, right? So I don't want to start with n equals 1. I want to start with n equals 2, because n equals 2 is going to be 2 minus 1. That gives me the first guy, right? Okay, so we're always going to think about that. Hey, I need, in order to find these, in general, I need the first term, and I need to know what the difference is, and then we'll plug in and figure out what the nth term is that you're wanting me to find, so to speak. Okay, so here we go. We've got this sequence going on up here above, so I'm just going to ask a follow-up question about that. What is the 50th? What is the 50th term in that sequence that we had a second ago? 3, 8, 13, 18, ... Okay. So again, I don't want to figure out the 50th term by hand, so hopefully we can use this formula here to make everything good. Before I plug in for the 50, I want to know, I'm just going to make the generic, okay? So the general looks like a sub n is equal to, what's my a sub 1 up here, my first term? The very first term is a 3, okay? Plus, I don't know what my n is yet, but I'm going to do n minus 1. And what did we say the difference was? The difference was a 5. Okay. If you have a little bit of trouble like identifying what the first term is, aside from the fact that I just said the first term, you could always come in here and like put little arrows and say n equals 1. Here, n equals 2. Here, n equals 3. And like identify, okay, this is the fourth term, right? So n equals 4. And figure out what the n is that goes along with that. So where people get problems in this is because they'll be working along and they'll say, oh, I need the fourth term, and then they'll go back and they can't quite line up. Where's the fourth term? Where is it that n equals 4? And what is the number in the term? So this is the fourth term. Okay, so, and that would be a sub 4, right? Okay, so you need to be able to keep those two straight in your brain, and that is sometimes very difficult. Okay, so here's my generic, and then I want to plug in, we said find the 50th term, so everywhere that I see an n here, I'm going to put in a 50, a sub 50, 3 plus, it's going to be 50 minus 1 times 5, right? Again, I don't need to figure out 50 total terms here because we already know the first one, right? So I'm going to be figuring out what's 49 terms after that first one. That's why we have that little arithmetic step in there. So a sub 50 is 3 plus. We know that that's 49 times 5. And whenever I do that math, I come up with 248. You can double check me and make sure. Okay, but I think, so what does that tell me? I think that the 50th term is 248. The 50th term in that sequence. And again, we were only at, way up here, we were only at 38, right? So I don't want to have to go all the way to the 248 for the 50th term. So be aware of that. Okay. If you don't know the general formula, so again, maybe put a little star here or something to put that in your notes. Make sure you have that somewhere. You're going to need those whenever we take test 1 I will provide some of these to you. I don't expect you to memorize formulas, but you're going to need it in your homework and stuff like that. So if I don't have the general formula, then the least I can do is maybe I can find the recursive formula. That one's actually pretty easy. It always looks like if I want the nth term, then what I need to do in a recursive formula is I need to find the a sub n minus 1. So above, the question above, I would have, to get the 50th term, I would have had to find the 49th term, right? Okay, so a sub n minus 1 plus the 5 in this case, or we'll say, well, for the general it will be plus the difference, right? Okay. So, but in this case right here, it would have been the 5, which was the difference. Do I want to do this 50 times and figure that out? What's the 40th term plus the 5, which was the difference? No, I don't want to do that. So this recursive formula is only really useful if I'm only looking for maybe the 4th term or the 5th term or something like that. As soon as I go, hey, how many haystacks does it take to fence in 200 cows, then you're going to have to go, oh my gosh, let me not do 200 of these, let me find a general formula, right? Okay, so here's another example. Let's get it out here. Example 4, I believe we're up to. Okay, and it says write a formula for the general term for 2, 6, 10, 14, 18, ... So we're going to sit there and we're going to say, hey, what's my general pattern that's going on in here? So hopefully you guys can see it. What do you think is going on? Okay, I think it's plus 4, right? Plus 4, plus 4, plus 4, plus 4. I definitely see a plus 4 going on in there. So I'm going to say that my pattern is that I'm adding a constant of 4. Does everybody agree with that? Plus 4, plus 4, plus 4. So whenever I see that and I say, hey, we're adding a constant, that tells me what kind of a sequence is this? Oh, it's arithmetic, right? This is arithmetic. Okay, well, if I got that going on for me and I know that it's arithmetic and they want me to find the general term, so that's a sub n, right? Then I just go back to my formula that I know. The general formula is a sub n is equal to a sub 1 plus n minus 1 times the difference. Okay? And we have all of that information right in front of us, right? So a sub n is equal to, a sub 1 was the first term, right? So here it is, 2 plus n, I don't know because I'm doing general here, so n minus 1, and what did we say the difference was? A 4. Okay, so there it is. Now what happens though is as I go along, I go, hey, I can simplify that. So this is kind of like what I would see as I go through and I see a general pattern. I would see something like that, but unfortunately, for the actual final product, it'd be nicer if I had something nicer looking than that, right? So what can I do here? Yeah, I can distribute that 4 through, right? So a sub n is 2 plus 4 times n is 4n, and 4 times 1 is 4, but it's a negative, minus 4. So now I can combine some like terms and make that even prettier. A sub n is equal to, and I'm going to move the 4n out in front, 4n plus 2 minus 4 is minus 2. Look how nice and pretty that is. Okay, now here's the deal. If you had that and you gave me that on a test, check, it's okay, right? But if you have this and you give me that, check, check, right? extra brownie points for being able to simplify that and make it prettier. But I'm not going to penalize you if you have this. It just looks a lot nicer if I have that. And it becomes a lot easier to say, hey, what's the 50th term? Because all I have to do is plug in here. 4 times 50 is 200. Minus 2, I get 198. It's very fast. It's very easy for me to find the next. The 200, or what did I say? The 50th term. Okay. Whereas in here, I'm going to have to do a little bit of arithmetic and do some stuff before I can find that 50th term. Okay. All right. One more kind of sequences. So we have this one that's arithmetic that we've been talking about. And then there's another kind. And I think y'all are going to have to get 2 videos here. So I think it's going to be 3 videos all together. But I'll come back whenever it's finished because this is already getting to be a long video. So I'm going to finish this definition and then I'll come back. Okay. So the other kind of sequence is geometric sequences. Okay. Maybe you've heard that before. A geometric sequence, unfortunately, it's not really about geometry. Okay. It's a sequence that has a pattern of multiplying by a constant. Okay, so the difference here is before I was adding a constant, now I'm multiplying by a constant to get from one term to the next. And you've seen these before, I know you have. Okay, to get from one term to the next. And in this case, what we call it is the ratio between the two, and that's going to be my R. Okay, so that's the ratio, and it's between any two consecutive terms. Okay, so R is going to be my variable here, whereas in the arithmetic, D for difference was my variable, right? Okay, so as I start working through these, an example of this would be, again, y'all have seen some of these before. I know you have. It just sounds a little funny with that word geometric in there. So example 5. Sorry, my thing's sliding. Example 5 says you've got these terms 2, 6, 18, and 54. Write the next 3 terms out and find R. Okay, so dot, dot, dot. Write the next 3 and find R. So again, when the directions say something like find R, I know, oh, I'm looking for a ratio. It's not a difference. I need to just kind of think about it. What do y'all think's going on in here? Again, inside here, I see times 3, times 3, times 3. I can see the multiplication happening. Hopefully you can see it happening too. If not, if you're not quite sure what's going on there, it's a ratio, right? So I could do 54 divide by 18, punch that on your calculator, you should get a 3. And it's between each of the consecutive terms. So 18 divided by 6 better give me a 3. And 6 divided by 2 better give me a 3. So I know here that my R is equal to 3. That's my ratio. I'm multiplying. That's my constant that I'm multiplying by. And then once I know that, oh, that's pretty easy to find, right? The next 3 terms. I can say, oh, take 54 times 3, right? That guy is 162. Check me and make sure. And then once I have the 162, I can multiply him by 3. Well, that's 486. We're getting really big really quickly. This is one of the differences between geometric and arithmetic is that sometimes these get really big because, or really tiny small fractions depending on which way I'm going, but they get really big really quickly because I'm multiplying by a whole number here, right? So last but not least, 486 times 3, I've got 1458. So check my arithmetic on those. 162, 486, 1458. That's what I think the next 3 terms are. You can check me in, oh, 14, 58. Check me and see. All right. So we found the R, and we've got the next three terms. Move that up. And I'm going to say, hey, there ought to be some way for us to find a general formula, right? So, and of course there is. Wouldn't be a math class if we just left you hanging on this one. There is a general formula for the nth term in a geometric sequence, any of them, and it looks like this. A sub n is equal to a sub 1 times the ratio, and my little arithmetic step here is in the exponent. So we're going to talk about that for just a second. All right. So looking at the sequence we just did, I wanted to leave it up there, but my paper is wobbly, so I'm moving it. So we had 2, 6, 18, and 54. So, and then dot, dot, dot. Just remember that. Okay. So let's think about this. We have the first term. It's a 2. And what did we do? We did times 3, right? And then we multiplied that by 3, but I could have just as easily said, so for the first one it was 2 times 3, gave me the 6. For the second one it was 2 times 3, and then I multiplied by 3 again, right? That gives me the 18. And for the third one it was 2 times 3 times 3, that was the 18, but I multiplied that by 3 also, right? To get the 54. And so a part of us says, hey, can I look at this and can I mess with it? And of course I can, right? The 2 is the first term. We can see that's my a sub 1. It's always coming in there. But now I see, hey, this was a times 3. There was only one of them. Okay? I was getting the second term here. So I don't want to multiply 3 times 3. I only want to multiply by itself once, right? So I start thinking exponents. This becomes 2 times 3 to the first. And this becomes 2 times 3 to the second. And this becomes 2 times 3 to the third. And what I can do is I can see, hey, how does this exponent relate to what term number I'm on, right? This was the second guy. This was the third guy. This was the fourth guy. So when I look at it like that, hey, on the second term, my exponent was a 1. That's 1 less than my term number, right? On my third term, my exponent was a 2. Again, 1 less than my term number. And on the fourth one, my exponent was a 3, and again, that's 1 less. So you can see why they're doing this little arithmetic step there, right? They're making an adjustment for the fact that you already have the first term in there, and on the first term we didn't multiply by 2, right? Or by 3. The first term was just the 2, so we don't need to multiply by 3 to get the first term. We only multiply after that to get all the other terms. So again, really important, put this in your notes. Make sure that you see that formula, because again we'll be using it. So an example of this, and this will be our last one for this before I come back and talk to you about some other stuff. Example 6. Okay, so example 6 says write the general terms. I'm sorry, I can't write today. Terms formula for. And here, this one's going to be a little bit tricky for us. We haven't done one like this yet, but we can do it. 192, 48, 12, 3, 3 over 4, 3 over 16, dot, dot, dot. Okay. So this is still geometric. I'll show it to you in a second. But whenever I look at it, I'm like, oh, hang on. They're not multiplying, they're dividing. Now, if you think about it as dividing, that's fine. I'm certainly dividing by 4 there. And I'm certainly dividing by 4 there. And I'm certainly dividing by 4 there. And here's where we can really see it, right? We go from 3 to 3/4. Well, what did I do to that 3? I divided by 4. And from 3/4 to 3/16, again, I divided by 4. So I can see that I'm dividing by 4. The problem is that I said, hey, I'm always doing something that I'm multiplying here, right? So my ratio, I'm looking for my ratio, right? So remember, the ratio needs to be something that I multiply by. Multiply by a constant is what we said to get that ratio. Okay, so if I'm looking for that, I need to be multiplying, not dividing. So what can I do with this that'll give me a similar feel for it, but not be dividing? And sometimes I say, hey, look right here. Yes, I divided by 4, but I also could have said I'm multiplying by 1/4, right? That would have given me, if I put that right there, 3 times 1 is the 3 on top over 1. 1 times 4 on the bottom. Yeah, I'm multiplying by 1/4. My pattern is multiply by 1/4. And by the way, it's the fact that I'm multiplying by a ratio that's less than 1 is the reason why my numbers are getting smaller, right? If I was multiplying by a ratio that's 1, it would stay the same. If it's bigger than 1, then it's going to grow bigger. Like the last one we saw, we had a ratio of 3. That makes things grow bigger. Here, my ratio is less than 1, so that makes me get things smaller. Does that make sense? Alright, so I don't have to work too hard though. I need my ratio, and then come back up here. For the general formula, I need my ratio. I got it. And I need my first term, right? So I need to come back here and say, hey, what's my a sub 1? It's the first term. What's my first term? 192. So this one looks a little bit different because it starts out with a big number and then it works its way down. But it's not that big of a deal because as long as we have a formula, we can just work it out, right? So again, the a sub n guy was a sub n is equal to a sub 1. Well, what's that? 192. We got it right there. Times my ratio, well, what's that? 1/4 to the exponent n minus 1. And there we go. And if you're not sure about it, then you can kind of check a little bit and see what's going on. And let me do one that I feel like I can do pretty easily in my head. Let's do if n equals 3. That's not horrible. I can do that. So the third term here, whenever I finish, I'd better get a 12, right? Because I'm trying to find a sub 3 by using my formula. It's 192 times 1/4 times, or raised to the 3 minus 1. And I'm just going to go ahead and say 3 minus 1 is 2. Is that okay? All right. 1/4 to the second power. Well, I know that 192 times anything squared here, if I got a fraction, I square the top. 1 times 1 is just 1. And I square the bottom. 4 times 4 is 16. And then I know, hey, I can write that 192 over a 1. This is the same as 192 divided by 16. And if you're not sure, you can just start dividing these out. But I know for a fact that this should be divisible by 4. That would be 48. And this should be divisible by 4. And then I know for a fact 48 divided by 4 is 12. So I indeed got the 12 that I should have gotten. So that was my a sub 3. Okay. I wasn't after that. I was just checking my answer, right, to make sure I got one of my terms. And here is the general, right? That was what I was really after. Okay, what was the general formula for that? Okay, so that is it for talking about sequences and series. We're going to come back and I'm going to give you a little bit of an activity thing and talk to you about what your homework for the week is. So coming right back up. Yay!